So the topic that we are going to take up today is current electricity. First of all, let's get down to it. Sir, what exactly this name means? You say that current is what? Now current, people think that only this current, sir, the one that is moving in the wires, this is the current. No, this term current comes from a simple term called flow. Now you guys must have heard about this, that flow of water, don't we call it water current? Yes. When, let's suppose I am touching a spoon to a stove, gas stove, what happens? I feel the heat, or that spoon is getting hotter. Who is responsible? Sir, that means heat is traveling to you. Sir, but how? Because of thermal current. Sir, what is thermal current? Heat energy flowing is called thermal current. Water flowing is called water current. And charges, when they flow, you say that it is electric current. Now our topic revolves around this one term that is called charges. So sir, are you saying that the flow of these things that you are saying, charges, the flow of this charges is called current, and this is the chapter name? Yes. Now understand this in one go. What are charges? Now definition, if you ask me, no one is going to ask you, right? No one is going to ask you what define charges. No. Yes, but you should have the proper feel that what are charges. Charges are nothing but, it is a property of matter. Simple 2-3 words. It is a property of matter. Sir, what do you mean by that? Matter, every one of you know what is matter. Sir, something that occupies space or volume. Yes. Now, you can give this property called charge to any matter. Now, sir, we are also matter. Yes. So, sir, are you saying that we can also attain charge? We do. Many times you must have, realized this. Sir, I was sitting on a chair. I don't know what happened. I stood up. I touched something. I felt a shock. What is that? Your body was charged. Sir, in my childhood days, I used to, rub my comb or a scale with my hair. And you know what? It used to attract the bits of paper. What did you do? You charged the scale by rubbing it. Now, this charge, what do you call? It is nothing but a property that can be given. Charge is not like, I will say, wait, I will show it to you. I will take it out from my pocket and I'll say, oh, this is charge. Not happening. For charge, I need a body. A body basically, which is matter. If I have matter, I can give this charge to that body, and that body will be called a charged body. Okay. Sir, now I see positive and negative. Yes. Now, when I said, right, any matter can be given the charge. Now, there are two types of charges. One is called positively charged body. Positively charged body. And the second one is called negatively charged body. Sir, but how? How can you say that one body is negatively charged and one body is positively charged? For that, I will take you little to the microscopic level. Sir, what is that? All of you know what is the fundamental unit of what is like all the matter is made up of?
Atoms.
Atoms. Well done. Now, who will tell me what is atom like? Actually, atom looks like. What exactly atom looks like? If I say this is a sphere, this is the atom. They say, I don't know, I'm not saying, but they say that in the center there is something called nucleus. Do you know that?
Yes, sir.
What is present in the nucleus?
Protons and neutrons.
Very good. Protons and neutrons. Now, if I say that protons, sir, you have drawn, I don't know why, but you have put a positive charge on that. You did not put any charge on neutron. And I don't know why you are drawing these lines across it. These are called orbits. Have you heard this in chemistry? Yes or no?
Yes, sir.
Perfect. Now these are called shells. Oh, so this is how an atom looks like? Perfect. This is what an atom looks like. All of you focus. Now, why am I telling you about this atom thing now? See, if you understand and believe me, then I can tell you this, charge, the property that I'm saying that, I can charge a body. Sir, but how do you charge a body? How will it become positive or negative? I want to know that. Simple. I'll tell you, this charge, SI unit of charge is, can anyone tell me what is SI unit of charge?
Coulomb.
Coulomb. Right? Just like you measure length in meter, mass in kg, time in seconds, this charge is measured in Coulomb. Now, this electron that I am saying, that electrons that are revolving around that nucleus, the charge on this electron is equal to minus 1.6 into 10 to power minus 19 coulomb. Is it a very big value or very small value? What do you think?
Small.
It is very small value. Sir, how can you say that? 10 to power minus 19, you know what it means? It means divided by 10 into 10 into 10 into 10 into how many times? 19 times. So 1.6 divided by so many zeros, that is 10 times, 19. So it is a very small value. So sir, what is this? This is the charge that one electron has. Sir, you are saying the particles that are revolving around the nucleus, those particles have this much charge. Yes. And the charge, if you see the sign of the charge, is negative. These are the smallest charged particles. Similarly, you were saying that, sir, protons are also there. Yes. Now, protons also have the charge on themselves, but it is positive. Sir, what about the value? Value of charge on the electron and the proton is same. The magnitude is same, but the sign is opposite. One is negative, other one is positive. Simple, nothing to worry about. Sir, one has negative charge, another one has positive charge. Now, sir, I don't know why, but this looks like, very terrific number that, 1.6 10 to power minus 19. Sir, do I need to worry about it? You don't have to. You don't have to. I'll tell you what question they can ask you at maximum. But understand this. Protons and electrons have same amount of charge. One has positive, one has negative. Both are present inside the atom. Yes or no? Inside the atom, there is nucleus at the center where protons are present, and around that protons or this nucleus, electrons are revolving. So can I say an atom has both of them? Yes or no? Yes or no?
Yes, sir.
Yes.
What about neutrons? Do neutrons have any charge?
No.
No, the charge on neutron is 0. So these three particles are present inside the atom. This should be the first thing that you should know. Now let's get down to how a body can be positively charged and how another body can be negatively charged. First thing for that you have to understand is the protons can never come out. Sir, why? You only told me that protons are present inside the nucleus. Nucleus is, they are bound. They are tightly bound by strong forces. They cannot come out. If someone tells you that I took out a proton from an atom, he is a liar. He is a liar. But yes, electrons are someone who are revolving around, right? They are not at home. They are revolving around out in the streets. And yes, it is easy to kidnap who is in the streets. So these electrons that you see here, they are the ones who can be taken out of the atom. First thing, what did sir tell us? Electrons are the ones that can transfer, protons cannot transfer. Electrons can transfer, protons and neutrons cannot transfer. Why? Because they are inside the nucleus. They are inside the nucleus and they are strongly bound by strong nuclear forces. No one will let them go. They are inside the house, inside the home, nucleus. They cannot go out. But yes, the ones who are revolving around in the streets can be kidnapped. They can be taken out. So remember, electrons can be moved because of these forces. Sir, but sir, you are not coming to the point. You were saying that how a body can be charged and how can a body be positively charged and how a body can be negatively charged. That is the question. See, if I tell you, all of you check this out. If I tell you what is plus 10 minus 10. Plus 10 minus 10 is equal to?
0.
Plus 1000 minus 1000 is equal to?
0.
0.
Minus 2.5 plus 2.5 is equal to?
0.
0.
So can I say that if the positive and negative is in equal number, the result will be 0? Yes or no?
Yes, sir. Yes.
So sir, what are you saying basically? I am saying that if the number of electrons and number of protons are equal on a given atom, can I say the net charge on the body will be what? Zero.
Zero.
And such a body will be called what? Neutral.
Neutral.
Such a body will be called neutral body. So number of electrons, because electron had negative charge, proton had positive charge, but same amount, same amount. Now if I say 10 electrons are there, 10 protons are there, do you realize equal amount of negative, equal amount of positive, resultant will be zero. Is it very much clear to all of you? Say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
Now, still, sir, you are not reaching the point. You said you will tell how a body can be positively charged and how a body can be negatively charged. So let's get to the point. Now I have a neutral body in front of me. Sir, what is neutral? Neutral means number of electrons and number of protons are same. Now tell me one thing. If I put in the electrons, I bring some electrons and I put in these electrons inside the body. So now tell me one thing. Earlier, the number of electrons and protons were same. So if I add extra electrons, what do you think? Will the net charge still be zero?
No,
No,
sir.
sir.
No.
No. Earlier they were equal. But now, sir, if I say minus 100 and plus 90, what will be the result?
It will be negative.
Minus 10. So
Minus
that means
10.
the overall result will be negative. Say yes or no.
Yes, sir.
Now, this is the point. When electrons are added to a neutral body, which had equal number of electrons, equal number of protons, such a body will become a negative body. So are you saying that, sir, addition of electrons into a neutral body will become a negatively charged body? Yes. Yes. So this is what you call a negatively charged body. All of you, I hope you understand. Earlier, the number of electrons and protons were equal. Then you put some extra electrons. What happened? Sir, automatically it will become negatively charged because negative will be in dominance. It will be dominant. Positive is less. So obviously that net charge on the body will be negative. Such a body is called negatively charged body. Now tell me one thing. Forget that I added the electrons. Let's get back to the same body which was neutral. Now, sir, you said protons cannot be transferred. You said protons cannot be transferred. Now, I cannot say that I can bring protons and add into this. Can I say that?
Sir.
No. No. Why, sir? Because protons cannot be transferred. They are strongly bound. They are strongly bound. So what should we do in such a case, sir? Ji? You don't have to worry. You just have to take out the electrons. Electrons can be transferred. Yes or no? Now tell me, if I can't add positive, but can I take out the electrons out of this? Can I take some electrons out of this?
Yes.
Now tell me one thing. If I take the electrons out of the neutral body, do you realize that, sir, the dominance will be then positive? Yes or no?
Yes, sir.
Yes or no? Yes. This is the concept. First thing that everyone should know, if you want to study the entire concept of electric charges and electric current, you should have a clear-cut, picture in your head that how a body is negatively charged and how a body is positively charged. If, sir, there is a neutral body, understand. Neutral body, number of electron and proton are equal. You add electrons, becomes negative. You take out electrons, become positive. Sir, I will never ever think about taking out proton or giving proton. It is a sin. It is a sin because I should know that it is strongly bound. It can never be transferred, sir. Ji, if I am doing that, I am committing a sin. Is it clear to all of you? Say yes or no.
Yes, sir.
Yes, sir.
One
Yes,
simple property everyone should know, and I believe every one of you know this, that negative, repel each other.
Repulse.
Positive,
Repulse.
neutral bodies,
Don't do-
neither repulsion
And
nor,
neutral.
yeah, it will now neither attract nor push it away. And last one, positive and negative attract each other.
Attract.
Now, do you want me to sum this entire picture in one line? Check this out. This is how they will ask you the question. This is how they will ask you the question. What will they say? You have to remember this one line. Like charges, complete it.
Repel each other.
Repel each other.
And unlike charges,
Attract each other.
Attract each other.
very good. Like charges repel each other, and unlike charges attract each other. All of you write this single point property of charges, that how do they behave. Repulsion for like and attraction for unlike charges. Positive negative is always going to attract, and negative negative, positive positive, they are going to push each other away. Can we remember this simple property?
Yes, sir.
All right, all of you, if you guys are writing it down or you are writing the notes, right? Don't worry if you miss out on something. I will be sharing the recording. You can pause and you can, note down the notes. Is it clear?
Yes, sir.
Yes. Okay. If you want to take, you can take screenshots also whenever you wish to. Moving on to the next topic. Sir, okay, understood. You are saying there are electrons, there are protons, and you are saying bodies are charged. Simple, understood. Whatever you wanted to make us understand, I understood. And last thing you said, positive is going to repel, negative is going to repel, positive negative is going to attract. Now understand this one point. Electric current is the topic, sir. Sir, electric current. Yes, I understand. This is the topic. This is the first topic according to NCERT. But tell me one thing. Do you remember that electric current is nothing but the flow of charges? Yes. When I say it is flow of charges, so should we have a good idea about charges? Yes or no?
Yes.
So now you know what are charges. Now let's start with what is electric current. Electric current, always they are going to ask you question out of these two chapters, something related to this topic they are going to ask in the boards. You can write it down, right? Now understand what is electric current. It is rate of flow of charge through a cross-sectional area. Through a cross-sectional area. Now students say, sir, why do you say this? Sir, directly why can't we say? Sir, you should have written, right? Charge per unit time is called current. Listen, technical definition is this. Because I'll teach you one thing. If I zoom into this wire, let's suppose this wire will look like this. Yes or no? Dhiru, will it look like this? Dheeraj?
Yes, sir, like the cylinder.
Yes. Now understand this. Understand this. Inside this, obviously, this is what? This is some matter or wire. Now, every wire has electrons, I can tell you. Every wire has electrons. But yes, there is one more thing, sir. Sir, I, tried to touch a copper wire with the live wire. I received a shock. But I tried to touch a plastic wire with the live wire. Will I receive a shock?
Yes, sir.
No. Why do your parents tell you that wear your sleepers while you are turning on or playing with your electric instruments? Why do they say that? Wear your sleepers. Do you know that?
Because the charge will stop when it hits the legs.
No. See, I'll tell you. See, there are two types of material. Two types of material. This term is used like anything, but you should have a clear picture what it is. Have you guys heard conductors?
Yes, sir.
Yes.
Yes, sir.
Another term is insulators. Sarji, what conductors, what insulators? Listen to this. Conductors are the material that say, come, you can go. So to whom? To the electrons. So the conductors are the ones that allow the flow of charge, whereas insulators, they stop it. They say, no, I won't let you go. Now, example, simple. Keep it in your head. Metals are conductors, and your plastic, your rubber, these are insulators. I am not going to write down the definitions. You can just, write it down yourself. What are conductors if someone asks you? Sir, the material that allows the flow of charge. Yes. And the one that does not allow the flow of charge is called insulators. Am I crystal clear to all of you? Yes or no?
Yes.
Yes, sir.
So now if I am saying that this is a wire, copper wire, what do you think? Copper wire is a conductor or an insulator?
Conductor.
Conductor.
So it will allow the flow of charge. Okay. Now understand this. There is such a huge wire, right? Now, when I connect it to the battery, you know that sir, current will, charge will start to flow, electrons will start to flow. Now, electrons are flowing throughout the circuit. Now, when I turn on the light inside my house, I don't know how much meter of wire is there, right, inside the wall, which must be, in the entire wire, the electrons must be flowing. But how do you figure out? How do you define electric current? Remember this. Now you stand on one point. Where do I stand, sir? Stand on this wire. Hypothetically, don't do it. Right. Now, hypothetically, if I stand on this wire and I know the electrons are going to flow, sir, positive charge, sir, the positive towards the positive, it will go. Yes. So electrons will start to flow from this. So you just have to notice that how many electrons are passing from this given area, this area. You don't have to measure all the electrons. Obviously, there will be billions of electrons that are flowing. But how do you measure? Sir, I stand here. I observe that how many are passing. Okay, let's suppose, sir, I say 100 are passing. 100 passed in 1 second. 100 electrons are passing in 1 second. Now tell me one thing. What is charge on one electron?
0.6 into 10 raised to minus 19.
1.6 into 10 to power minus 19. So if someone asks you what is the charge that has passed from this, can I say charge passing from this is nothing but number of electrons into the charge on that one electron? Say yes or no.
Yes, sir.
Yes.
E is the charge on one electron. And what is N? Number of electrons. So if you observe that 100 are passing, you just have to multiply your 1.6, because you should know E is equal to 1.6 into 10 to power minus 19. Sir, why are you not writing the sign? Because I know my students are intelligent. They can understand. We are only talking about the magnitude, right? What is the charge that is passing? Doesn't matter if it is negative or positive, but it is passing through the cross-sectional area. So if they are asking you the definition of electric current, all of you, remember what we write: rate of flow of charge through a given cross-sectional area or through the cross-sectional area of a conductor is called electric current. Is it very clear to all of you? Then I can move ahead.
Yes, sir.
Yes, sir.
Yes, sir.
Now, the formula says I is equal to Q by T. Sir, I is equal to Q by T. Yes, it is same. Rate of flow means what? Per unit time. How much charge is moving per unit time? What is 1 unit of time? What is 1
1
unit?
second.
1 second. So the amount of charge that passes through the cross section in 1 second. Now let's suppose Dheeraj tells me, Dheeraj say, sir, I was standing on the wire as you told me. I saw 100 coulomb of charge passed. 100 coulomb. How much? 100 coulomb. In how much time, I asked? He said, sir, I was noticing it passed in 100 seconds. 100 coulomb of charge in 100 seconds. Yes. Now what is the charge passing in 1 second?
1 coulomb.
1 coulomb, right? 100 coulomb in 100 seconds. So can I say 1 coulomb in every second? Yes or no? Yes or no?
Yes.
Yes.
That is correct. That is correct. Feel this entire concept that, sir, how we are measuring the amount of charge that is passing. And now I will not always, just notice in 1 second. I can also take in the question, they will say the charge passing through the cross section is this amount in 1 minute. Now, what would you do? Sir, if they are giving me 1 minute, they mean to say 60 seconds. 60 seconds, I will take the total charge, divide it with 60 seconds, I will get in 1 second. So the charge flowing in 1 second is nothing but current. The way to write it is rate of flow of charge through the cross section is called electric current. Am I very, very clear? Please just show me the thumbs up so that I can move on. All of you, please, quick. Okay, good. Zahra, Is it clear? Perfect, perfect. Hania, Vedika, let's move on. Perfect. Very good, Aisha. Let's get started. Now, electric current to theek. Done. Understood, sir. Rate of, you are saying the charge that is flowing through that cross-section area in 1 second, that is the electric current. Yes. But you know, examiner wants to ask you a little typical question. A little typical question. Now, what is the typical question, sir? They want to ask you that what is the unit of electric current? They will ask you what is the SI unit of electric current? Who will tell me? I believe you guys.
Ampere.
Ampere.
What is it?
Ampere.
Ampere, denoted by
A.
A.
Capital A.
Denoted by A. Now, see, they will always make it more difficult for you. You know what they do? Rather than asking define current, they will say, you can write it as a question because you will see this as a question. They will say define the unit of current, or they will say define 1 ampere of current. Sir, I knew the definition of current. I knew the SI unit. But how do we define this 1 ampere of current? All of you.
The time, the amount of charge flown through 1 second, right?
1 coulomb of charge. 1
1
coulomb of charge. Right?
Okay.
So what we say, write it down, all of you on the screen. Check this out. We write if 1 coulomb of charge, flows through the cross section in how much time?
1 second.
1 second.
In 1 second, the current flowing is said to be 1 ampere. And I can prove it. Sir, how? I can prove it. Check this out. What was the formula? Formula said I is equal to Q by T. Yes or no? If I take the charge as 1 coulomb and time as 1 second, do you realize that this will be equal to 1 ampere? Yes or no?
Yes.
So simple. When 1 coulomb of charge flows through the cross section, in 1 second, we will say the current flowing in the wire is 1 ampere. All of you, quickly write it down. Quickly write it down. Okay. Current done. Unit done. Definition of unit done. Sir, what else? Is there anything that is important other than this? Yes. Direction of current. Very much important. Sir, what is the direction of current? Now, if you ask me, I never say, it is positive to negative. I say it is opposite to. This is what I want you to remember. Direction is opposite to the flow of electron. Opposite to the flow of electrons. Sir, why? Now tell me one thing. If I say that, this is, you see in a circuit in front of you, you see a battery with a positive terminal, a bulb and a negative terminal. Now tell me one thing. The electrons that are there in the wire, in which direction the electrons will flow? Positive towards positive or away from positive?
From positive to negative.
Electrons will flow from
Negative to positive.
Yes. See, electrons are the one that are attracted towards positive. Negative is attracted by positive. So the electron flow is towards the positive side, from negative to positive. But you know what? To make your life more difficult, what they did? They said the current will be flowing, the direction of current we are going to take opposite to the flow of electrons. So if your electrons are moving towards positive, the direction of current will be taken as positive to negative. Always remember the direction of conventional current. The direction of conventional, why do I say that? Because this is for our easiness. The direction of conventional current is taken as positive to negative terminal. From positive to negative terminal. Is it clear to all of you? Say yes or a no.
Yes, sir.
Yes.
So if someone asks you electric current definition, I know it. Sir, what about what are conductors? I know it. Right? What is the unit? Ampere. What is the definition? I know it. Formula Q by T. Simple. These things you keep in mind. No question can go beyond this. Simple. Keep all the things that we have studied in the topic. Keep this entire thing in your head. You are good to go. Moving on. Next topic is a little one which students are confused about, and I understand your trouble. The next topic is, all of you take a screenshot if someone wants to. I'll move on. Don't worry, you will get the recording in the group. Next is electric potential. Many students complain. Many students, sir, electric potential, sir. Sir, I don't know why, sir. They are teaching current electricity. In between, they talk about work done, work done. And work done was something we studied in 9th grade. And in 10th grade, they are talking about that. I understand your trouble. But guys, if you feel the physics, it is easy. Now I'll try to make you feel the physics, right? I don't want to go very much technical. I don't want to tell you that I teach senior classes and all. I want you to just have basic idea that why do they say that it is the work done to bring a charge from infinity to a particular point. This is the definition, right? Now what is the reason behind this definition? All of you on the board. What is this? What is this I have drawn?
Positive charge.
Positive charge. All of you, can you see this? Yes or a no?
Yes, sir.
Now, every charge has a range. Sir, what range? Now, tell me one thing. If I charge my comb at my place, will it attract the bits of paper from your house?
Yes, sir.
No, sir.
Even it cannot even attract, sir, a pieces of paper lying in front of you at a distance. Right? Even if you are placing it down on the table, it will not attract. You have to bring it very close and it will clinch. It will stick to it. Say yes or no.
Yes,
Yes, sir.
What is the point? Point is, every charge has a region around itself. A region around. Imagine in 3D. Imagine a spherical ball around this charge. Sir, what this spherical ball is? This spherical ball is basically the field. Sir, which field? It is called the electric field of the charge. Sir, what is this field? Like, what exactly it does? See, it means that when you bring any charge, other charge inside this electric field, this charge can attract or repel it. If it is positive, go away. If it is negative, close. But yes, that other charge has to be inside this electric field. Otherwise, this charge will not attract or repel that charge. Is it clear to you? Every charge has a certain region around itself where it has the capability to apply the force of attraction or repulsion. Now that area or region is called electric field. But sir, you were trying to explain electric potential. You are explaining electric field. Related. They are related. You know why? Check this out. I have a positive charge, a little positive charge. All of you, tell me one thing and make my life easier a little. If I say that, this is the charge, it is lying very far off from the positive charge. This small charge is lying very far off. Sir, what is very far off in physics? In physics, very far off is infinity.
Infinity.
Right? Very far off in physics is infinity. Something that is impossible for you to reach. Now, what I say is, I start to bring it close to this. As soon as I will enter the field, you guys tell me, will this bigger charge start to push me away? Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Yes.
Now, if I want to bring it to a certain point, do you realize I will have to constantly pull it? Because,
Yes, sir.
sir, positive one, bigger charge is trying to push it away. So if you have to bring it inside the field, you have to apply a certain amount of force on this charge, then only this charge will be coming inside. Now, when I say I am applying the force, I am the external person. I am not the part of the system. I am the external one. I am helping the charge to come to that place. Now tell me honestly, all of you, I know you guys studied in 9th grade online, but someone must have told you one thing. Try to recall. If the force is applied and displacement is done, work is said to be done. Say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
The force is applied and displacement is done, the work is said to be done. So now tell me, to bring this charge from infinity to this particular point, do you realize that I must have applied force and I have displaced it? Do you agree with me that
Yes,
I
sir.
did the work?
Yes, sir.
Yes, sir.
This is the work they are talking about. This is the work they talk about. They say the work done, all of you, the work done in bringing a charge, from infinity to a point is called electric potential of that point. Electric potential of that point. Better to write bringing a unit charge. Unit charge, yes. 1 coulomb of charge. 1 coulomb of charge. Right? Sir, but what if I bring a bigger charge? What will happen then? Nothing will happen. You can just multiply it. Sir, multiply with what? Check this out. You say that the work that you do on 1 coulomb of charge in bringing 1 coulomb of charge, if that is your potential, it is denoted by capital V. So understand, this V can be written as work done per unit charge. Work done per unit charge. What is the unit of work done?
Joule.
Joules.
Joule. What is the unit of charge?
Coulomb.
Coulomb.
So can I say the unit of electric potential will be joule per coulomb?
Yes.
Yes, but do we call it joule per coulomb?
No.
No. Joule.
What is the SI unit of
Volt.
Volt.
Very good, very good.
Sir,
Intelligent.
what is creating this potential difference in
What is
the
it? This is
conductor?
in the conductor battery. If you're talking about circuit, electric potential, for electric potential, what do we apply? We have to have a live socket, or we have to have a battery. Do you realize this? Now, this is a single charge I'm talking about. Around that already there is an electric field. But for wires, who is the one who is responsible for creating such an electric field? The battery. The battery or a cell, right? Is it clear? Whoever asked this, please confirm.
Yes, sir.
Good, good. The SI unit is volt, not 1 volt, volt. All of you, write it down. Volt. But see, again, they will make your life little difficult. Sir, how? They will ask you, what is 1 volt? Now you guys are experienced. You heard one definition from my side. How would I write this? Check the formula. Work done upon charge. Can I say, if 1 joule of work is done in bringing a unit charge from infinity to a point, the potential of that point will be 1 volt. Can I say that?
Yes.
Yes, sir.
So what will we write? When the work done in bringing 1 coulomb of charge from infinity to a point, the work done in bringing 1 coulomb of charge from infinity to a point is 1 joule. The potential is said to be 1 volt. The potential is said to be 1 volt. All of you, these definitions are gold for you. One definition for sure, they are going to ask you in boards. So make sure you write it down. So you can say, sir, because I know volt is equal to what? Work upon charge. 1 joule of work and 1 coulomb of charge will result in 1 volt. Can we remember this? Say yes or no.
Yes, sir.
Good, 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 good.
Sir, just hold a minute. I'm writing down volt.
Yes, yes, please. All of you, take a screenshot also. I'll take your questions in the last. I'll take all the questions in the last, please. Because we are very limited on time and I want to touch everything. So please. Dheeraj, for sure I'll answer your question. One is magnetic field is due to magnets. The region around a magnet is magnetic field. The region around the charge, the region in which a charge can apply force is electric field. The region in which a magnet can apply the force is magnetic field. Right? All of you, please take a screenshot. Moving on. Components of electrical circuit. Direct question can be asked. That is why this question is important. This topic is important. All of you, I am going to quickly write it. You have to support me in this. Check this out. What is this? A wire.
Wire.
What is this?
Diagram.
Junction.
What is this?
Open
Open
key.
switch.
What is this?
Closed
switch.
key.
I am going to write it. Don't worry. Then you have this. What is this?
Rheostat.
Yes.
Then what is this?
Rheostat.
That is
Yeah.
rheostat.
What is this?
Battery.
Bell.
What is this?
L.
Battery.
Battery.
What is this?
Ammeter.
What is this?
Volt.
Voltmeter.
What is this?
Galvanometer.
Galvanometer.
Okay, all of you. Anything left? I don't think so. Check this out. A wire, a connecting wire. Then yes, a junction.
Junction.
Junction is where three wires are meeting at a point. That point is called a junction. This is confusing. Students say,
Open circuit.
yeah, they say that, sir, this is closed. No, this is open. Like there, the current cannot pass. So that is why it is called open circuit, or you can say open switch. And in the bracket, you can write open means off. Switch is off, right? Then this is closed switch. Closed switch means that circuit is on. This one, resistor. This one, rheostat. What is rheostat? Variable
Resistance.
resistor. Right? Just understand this one thing. You will see a box in the physics lab. You will find it. You just keep on turning the knob and the resistance changes. So such a device is called rheostat. This is a cell. This is a battery. Group of cells is called a battery. Ammeter and voltmeter and galvanometer. These are very important. Ammeter, voltmeter, and galvanometer. I am going to wrap it up in one line. Sir, what is ammeter? Device used to measure what?
Current.
Electrical current.
To measure current. Okay. How do we apply this? In series or parallel?
Series.
Series.
They are always applied in series. Voltmeter, device used to measure electric
Potential.
electric potential difference. Potential difference. Now, when I say for difference, obviously you have to connect it at 2 points. Now they will be connected in series or parallel?
Parallel.
Parallel. What about galvanometer? Device used to what?
Test the presence of current.
Detect the flow of current. Detect the flow of current. Well done. Very good, girls and boys. Check this out. But the direct question that can be asked: what define ammeter? What is ammeter used for? Device used to measure the current. Sir, what is electric potential? Voltmeter used to measure electric potential difference. How are they connected? Very important question. Series for ammeter, parallel for voltmeter. Galvanometer, it detects the flow of current. It detects the flow of current. It is something like this. It looks like this. You know, whenever the current will flow, it will deflect like this, left or right. That is indicating current is flowing. If it is not deflecting from its position, then you can say that no current is flowing. Is it clear to all of you? Yes or no?
Yes.
Yes, sir.
Perfect. Don't worry. Notes you can make easily after the class. You will get the time. Ohm's law. Ohm's law, very important. Definition. the statement, what exactly Ohm's law said. It said if all the physical conditions like temperature, students write it down as it is, temperature, pressure, etc. are kept constant, the current flowing in the conductor is directly proportional to what? Potential across it. Now, many of you must be thinking, sir, why are you writing this if all the conditions like temperature and pressure are kept constant? See, every one of you must have heard V is directly proportional to I. Yes or no?
Yes.
Now, when you have to remove this proportionality, you use a constant. What is that constant called?
R.
Resistance. Now, you only said that the constant is R. You know what, students? If the temperature is changed, this resistance will also change. So this entire statement has a particular condition. And what is the condition? If you want to impress the one who is checking your paper, you want to impactfully say the statement, you would never say that, okay, sir, current is directly proportional to potential. The world knows. The world knows that. What is different that you know? How would you get that brownie points? Write a statement like this. If all the physical conditions like temperature, pressure, etc. are kept constant, the current flowing in the conductor is directly proportional to potential across it. So if I see the circuit will look like this. This is, let's suppose, an emitter. This is, let's suppose, a battery. Now, how do you apply this voltmeter? Sir, in parallel. This is the resistor. This is the emitter. If I am going to change this battery, right? If I am going to increase the voltage of the battery, the current that will be passing in this wire will keep on increasing. So more the voltage, more is the current. More the voltage, more is the current. Right? Now some students say, sir, can't I say that current is more and then voltage is more? Tell me one thing. If you want to flow more current, will you change the battery, or you can change the current and then increase the voltage of the battery? What is practically possible? Changing the voltage of the battery, is it possible that you can change the current and the voltage will change? Is it possible? Is it possible? No. So voltage is the primary factor. You can increase the voltage of the battery and automatically the current in the resistor will be increasing. And the most important thing they ask in this is the graph. How does the graph of this look like? Sir, V is directly proportional to I. If you have this resistor, anytime you have a relation, direct proportionality, right? Direct proportionality, you can draw a straight line. Always remember, they are going to ask you, draw the variation of V versus I. So how would I draw it? Sir, V, I, and I can clearly say that this is how the variation will be. As your current is going to increase, your voltage is also going to increase along with it. So this is the straight line graph that you get for V versus I variation. Now I have a little question before I proceed. All of you, if you know this, well and good. If not, just listen to this very carefully. I draw two lines like this. I say this is the graph of V versus I. I say this is A, this is B. Who will tell me that whose voltage is more? B or, so whose resistance is more? B or A?
B.
A or B? B or A?
A.
Fast.
B.
Always remember the one that makes more angle with the current axis, right? The one that makes more angle with the current axis will have more resistance, right? So always remember, because theta A is less than theta B, the angle that B is making with the I axis, if that is more, sir, I will say resistance of B is greater than resistance of A. Is it crystal clear to all of you? Say yes or no.
Yes.
You have to check it with the current axis. Now don't be confused. Let's suppose the examiner is smarter than what I am thinking. Sir, what will he do? He can change this. he can shift I to the y-axis and V on the x-axis. And he will give you the same question again, B and A. Now tell me, whose resistance is more?
A.
A. Right? What did sir tell? The one which has more angle with the current axis, that will have more resistance. In this case, resistance of A will be more than resistance of B. So anytime you see such a question, over. Right? Over. Okay, I am moving on, please. Resistance of a conductor. Sir, what is this topic? You said now that there is something called resistance. Now this resistance actually depends on few factors. Sir, what are those factors? One is called length of the conductor. Second is called cross-sectional area. And third one is called resistivity of material. What type of material you are using. Fourth one is called temperature. We don't talk in detail about temperature at your level, but yes, you can write that also as one of the reasons or as one of the factors. So the question is these are the factors on which basically, you know, your resistance depends. Now tell me one thing. What is resistance? What do you think resistance is? Who will tell me? What is resistance? Students, please. Please.
Property of
Property of obstruction to electric current.
Yes. So can I say resistance is basically the obstruction, stopping the charge flow? Yes or no? Opposition of flow of charge. Yes or no?
Yes, sir.
Yes. So if I say more opposition means more resistance, say yes or no?
yes,
More opposition means more resistance. More resistance means, sir, they are not allowing the electrons to flow. Now understand this. If I draw two wires in front of you, one is this one is this one. You clearly see one has more length, other one has lesser length. Now, if the electron wants to pass from one side to the other side, he wants, you know, the electron charge wants that I want to go to the other side. Now, if the path, obviously, you know, it's not a walk in the park for the electron that it will enter. Wow, sir, how green it is inside and he will come out. No, obviously there are millions of electrons. And when there are millions of electrons, you know, you to pass through and penetrate through that all the electrons and reach the other end, it is difficult. That is why we talk about resistance. Yes or no? Yes. Now understand this. If I say there are millions of people on the road, right, and you have to reach the other side of the road, my question is simple. What would you prefer? The road should be shorter or longer? If you want to go to the other end, road is full of people who are pushing each other. What would you prefer? The road or that phase for which the people are standing, that phase to be shorter or longer?
no,
Shorter. Why? Because, sir, it will be easy for me to, you know, push through the people and reach the other end in shorter length. If I say I take the long route, if I take the longer route, obviously I will have to, you know, push the people away and pass to the other side, and it will be more difficult. Now, if I ask you, in both the cases, resistance is opposition. Your opposition will be more in which case? In the longer route. So can I say R is directly proportional to length? So directly proportional, yes. More the length, more is the opposition, more is the resistance. Yes or no?
Yes, sir.
yes,
Now understand next point. If I have two wires, now length is same, but one is narrower, other one is broader. Now you as a person think about it. There are millions of people on your way. Now what would you prefer? This road to be very narrow or to be broad? For you to become like, for your journey to become easier, what is preferable? Broader road or a narrower road?
Broader.
Broader road. So, sir, are you saying that if the road is narrower, more opposition will be there? Yes. Yes.
Yes.
Now that means lesser the area. more is the resistance. And more the area, less is the resistance.
Inversely.
So that is why, see what we say, inverse relation. Do you understand why there is an inverse relation in this? Do you see? Easy. When the entire thing is broader, it is easy for you to pass. Whereas it is difficult for you when it is narrower. What about the last one, or resistivity? Now, obviously, sir, it also depends on the material. So the material factor is taken care by resistivity. If I have a rod which is plastic and the other one which is copper, obviously, you know, sir, current will easily flow, charge will easily flow in copper. So resistivity is also, what is the other term for resistivity? Specific resistance.
Specific.
Also remember, it is also called specific resistance. It is also called specific resistance, right? So remember, this is something that depends on material. Depends on material. What type of material you are using to make the rod or the wire. Last one, temperature. Keep it in mind just to write if they ask you the factors. They are not going to ask you questions related to that, because that is something we study in 12th grade, right? We'll study that, but in 12th grade. But yes, you should know that if the temperature changes, the resistance also changes. Sir had told me once, right? Keep that in your head. You are good to go. Next is combination of resistors. I'm not going to talk much. Quickly, I'm going to wrap up this thing. Resistors, you know already, some students told me, sir, series and parallel. That means they already know what is series and parallel. We'll have a session, you know, don't worry. I'll see if we can have a session. Not after your maybe exams, we'll have some sessions just for practice. Some students ask me to practice these questions on resistors. So we'll plan that out. But today I'll quickly tell you what exactly the situation is in both the cases. So see, these are the two arrangements. R1, R2, R3. This is how the circuit may look like. Now, what important things you have to take care of? This one is obviously series arrangement. The other one is called parallel arrangement. Are say yes or no? Is the energy over?
Yes.
Yes, sir.
Energy is over. Very good.
Yes.
Nice. All right. So this is series arrangement. This is parallel arrangement. Don't worry, we'll have Kahoot also in the last. So if I say what are the important points I need to remember? See, what is R equivalent in the case of series? R1 plus R2 plus R3. So direct addition. Yes. Sir, what is R equivalent? R equivalent is if I want this circuit and I want to remove all the three and replace it with one, that is called R equivalent. Sir, but will it do the same work? Yes, it will do the same work. Whatever it was, the three combined they were doing, the same work will be done by this R equivalent, right? And remember the very important point about series. If the current goes from positive to negative, Nafa, if I say the current goes from positive to negative, do you see that it will eventually has to pass from all the three? Yes or no?
Yes.
Yes. So basically, your current passes from all the three, and you can star mark and write in series. The current through all the resistors is same. The current through all resistors is same. Right? This is the important point you should remember. Talking about, sir, this one. This is written as 1 by R equivalent. That is, I can replace these 3 by 1 is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, if this is the resistance, guys, this is the resistance equivalent. The important point is, now you tell me, Dheeraj, if I say the current comes here, do you think that this entire current will pass through all the three?
Yes.
It will be
Oh,
divided.
sorry. No.
It will be divided. Some amount of current will go here, some will go here, some will go here. Are I say yes or no?
Yes.
Divided. Now it will again recombine, and on the second side, same current will go. Now my point is, sir, then current is not same here. I see the current in first one, second one, and third one is I1, I2, I3. So what is same? Star mark and write it down. Star mark and write it down. What is same? The potential difference across. The potential difference across the potential difference across the resistors is same in parallel arrangement. In the case of parallel, the potential difference is same. Sir, how can you say that? Now tell me one thing. Do you see all the left sides of these resistors? All three, it is connected to the positive side of the battery. Right side of these resistors is directly connected to the negative side. So such a case, whenever you see that, sir, they are connected with the positive and negatives of the battery, I can directly state that the potential across all the resistors is same. These things you can keep it in mind. And for formula, for your numerical part, this is what you have to keep it in mind. That question, theoretical question, whenever they will ask, they are going to ask you this. And star mark, and remember one thing, sir had told, today we don't have time for that, but derivations for the formula. Derivations for series and parallel. Both you have to do, right? Go back, check your NCRT, right? If you guys have any doubts, don't worry. I'll take up one doubt session. But yes, go through it because that is also important from board's perspective. Moving on. Heat, energy, and power dissipation. What is heat energy? See, just remember one thing. And sir, why heat energy we talk about in electric current? See, understand this. Did I tell you that electrons flow in the current? Electric current is nothing but flow of electrons. Yes or no?
Yes, sir.
Yeah.
Yes. Now tell me one thing. Is it only 1 or 2 electrons that are flowing, or millions and billions of electrons? Now tell me one thing. So if I say, sir, you have connected this to the positive side of the battery, this to the negative side of the battery, sir, I know one thing for sure. Electrons are going to move towards positive. Now the point is, are they going to move in a straight line? No. Ask me why.
Why?
Because there are collisions. When so many people try to move on a road, obviously, will they collide with each other? Yes. When they collide with each other, there is release of energy. Their energy is released. They have, when something is moving, what type of energy do they possess? Anything that has motion, what kind of energy do they possess?
Kinetic energy.
Well done all of you. Kinetic energy. So that kinetic energy, when they collide with each other, that energy is released in the form of what?
Heat.
Do you realize that, sir? Many times I have seen, the wires and these, appliances at our home. When I touch them, they get hot. Why? Because for a long time they are running. Electrons inside them are colliding. And when they collide, their kinetic energy is released in the form of heat. That is why we talk about heat. Now, what is the formula? Formula of heat is VIT, or you can also write, what is I? Sir, V is equal to IR according to Ohm's law. Yes. Now you can put V is equal to IR. If I put in place of V here IR, it will become I square RT. And if I put I is equal to V by R in the same formula, it will become V square by RT. Now the point is, sir, do we need to remember all the three formulas? The answer is yes. They can ask you this direct question that which of the following is not the formula, or which of the following is a formula for heat energy. So all the three forms, we have just made it from VIT. But all the three forms, by using Ohm's law, V is equal to IR, putting V is equal to IR, or I is equal to V by R, you can do it. Now the next thing is, what is the SI unit of in heat energy? Come on. What is SI unit of energy? Joule. Yes. Joule. Right? Just keep that in mind. Right? Power dissipation. What is power dissipation? Heat energy per unit time, released per unit time, or dissipated. Heat energy dissipated. Sir, what is dissipated? Lost. Heat energy dissipated per unit time. So, sir, are you saying that we need to divide it with time? Yes. Power is nothing but heat upon time. And if you divide this entire, all the formulas with time, what will you get? VI, I square R, V square by R. Right? V square by R. So these three formulas for power also. Sir, do we need to keep them in mind? Yes, for sure. Any of the three formulas can be asked. So all of you, please quickly take a screenshot, or you can take it afterwards when the recording will be shared. Last topic is commercial unit. Who knows what is the commercial unit of electricity?
KW.
Kilowatt hour.
Kilowatt hour. Sir, what is this? Now tell me, I don't know how many of you know this, because here you don't involve in electricity bills. The electricity bill that we get, they say you have consumed this amount of units, right? So what is that unit? They say that you have consumed this amount of energy. What have you do? You have to do is, sir, nothing. Energy, you said, power is equal to what? Energy upon time. So can I say energy will be nothing but power into time? Are say yes or no?
Yes.
Now, what is power? In place of power, you just have to take it in kilowatt and time in hour. But sir, in the question, they have given me watt. So can't you convert it into kilowatt? Yes, you can. How? 1 kilowatt is equal to how many watts? 1000 watts. So if they give me something in watts, let's suppose X watt, I can convert it into kilowatt by dividing it by 1000. Do you agree with me?
Yes.
Yes. Right. So just by multiplying your power in kilowatt and time in hour, you will get kilowatt hour, and 1 kilowatt hour is equal to 1 unit of commercial unit of electricity. 1 commercial unit of electricity is 1 kilowatt hour. That's it for the lecture part. Now let's, all of you, be prepared. Let's get started with the quiz. All of you. 15 minutes are left. Let's get started. I am going to show you the quiz. All of you, be ready on the page where you have to fill the pin. All of you. Get to Kahoot, play Kahoot. Get to play Kahoot. And be ready on the page where you have to enter the pin. Okay. All of you. 8535038. Your name should pop up on the screen. I want all the students who are sitting in the class, all 35 students must be in the quiz. Don't worry, let's get started. Try it out. Good. Aisha, Rizwan, Madiha, good. Elvin, good. Minha. All of you should have your name pop up on the screen. When you join, the name will pop up on the screen. Quick. Good. We have 2 Aishas in the class. Very good. Aisha Muhammad. Okay. Very good. We already have 2 Aishas in Avanti also. Okay. Perfect. Goodwin. Perfect. Joel, Jaden. Okay. 26 are already in. All the students. Others, please. All the 5-6 students. Other than that, 10 students. Yes. Perfect. Fast. Ashline is there. All of you try to join fast. Okay, Ashline is here. Perfect, Ashline.
And how many questions are there?
Only 30. Easy ones, not very lengthy. No numericals. Just
V0.
your concept should be checked. Your concepts must be checked. Okay, I think I have to start the quiz because I am short of time. I can't wait more. Anyone who has not joined the quiz? Anyone who has not joined the quiz and is in the meeting, please. What is the problem? Just let me know. I think no one is there, right?
Sir, Ahmed didn't join.
Okay, no problem. The ones who want to join, quickly join. Let's get started. Okay, is there anyone who has not joined and wants to join? I'll take it as a no. Perfect. Let's get started. All the very best.
Sir, it's a bit laggy.
No problem. Try to manage, please. Good, good, good. Potential difference is voltage. Potential difference is voltage. I'll tell you a trick about this after the question, not now. No problem, this one. It's all right. Take care next time. Okay, all of you listen to this. Before the next question, all of you listen to me. Listen to this. Whenever the arrangement is in parallel, the result is smaller than the smallest. In parallel, the resultant is always equivalent resistance is smaller than the smallest. Here, what was the smallest? 1. So the result will be always be smaller than that. You can use the formula and find it. And in series, the result is bigger than the biggest. Bigger than the biggest. Right? So remember these words. In parallel, lesser than the least. And in series, more than the maximum. Move on. Fast, everyone. Well done. Well done. Fast, fast, fast. Well done. Focus, all of you. Good. Double points for this question. Now,
Sir, it's true, yeah.
no. Why? When you stretch it, the length is doubled, but radius will also decrease. I will talk about that. Don't worry, in the upcoming session. When you stretch it, length is increased, but the area is decreased. You forget about area. Good, good, good. Fast. Okay, fast. Quick, all of you. Keep what I said in your mind. What I said, keep that in your mind. Common mistakes.
The
Common.
answer is given, sir.
Fast. The one who has not answered fast. We are already over time. 4 hours. Because radius also decreases. Easy question. All of you must be correct. Must be correct. V versus I graph. Last 3 questions. Little calculative, fast. Voltage is given, charge is given. Work done. Fast. V is equal to W by Q. Remember that? Good, 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 good. If anyone would have any doubt, right, you can send it to me on WhatsApp. I'll surely try to answer, but be patient. Easy. Fast, fast, fast. Fast. Last question for the evening. Alright, easy. Power. Okay. Power it was power. Yes, it was not electrical energy, power. On that note, thank you so very much. Podium. Okay, well done. Ashar Nair, well done, well done. Nafa Ismail, well done. Great. Vedika, great performance, Vedika. Great performance. Aisha and Dheeraj, well done. You also. Right. I'll share the detailed report. Don't worry, I'll share it in the group. Thank you so very much, all of you. Right. First of all, tell me, how was this today's session? How was today's session? All of you, unmute yourself and you can talk.
It's
Yeah,
good.
it is good.
Good, sir.
Right. Perfect. Perfect. You learned something for sure.
Yeah.
Yes, sir.
Great. That is what is important. That is what is important. Well done, all of you. Hopefully, see you in the next session for magnetism. Magnetic effect of electric current is the topic that we will be discussing in the next class. All the very best. Keep on working hard. Right. Yes, Nafa, please send me the message on WhatsApp. I'll add you in the group. No problem. Right. But on WhatsApp number, you can send me the message. Right. Okay. Well done, all of
Thank
you.
you, sir.
Sir,
Welcome. 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 Have a good day. And now biology session. All of you enjoy yourself.
sir,
Yes. Yes. Yes.
tomorrow can I sit at home?